All right. Well, I guess first thing, I didn't really have a ton of details to give you guys about the test yesterday because we had to create it yet. So we finally had a chance to meet yesterday and talk about the test. I did upload the test outline for you guys. I put it on the weekly calendar and I put it on today's folder. Basically, there's going to be 10 multiple choice / short answer questions that are going to be taken in Schoology. And I know most of you said you just preferred the whole thing on paper, but the multiple choice in Schoology is kind of partially for Mr. Stouffer and I's sanity, because calc can take a really long time to correct. So that's kind of, so we did it half and half. So the other 4 questions that are going to be like the free response questions, basically you're just going to write out the entire thing on paper. And, I get it. It sounded like you guys really hate typing in on Schoology, and I understand. So the questions that will involve writing, you'll write on paper. What I'll do, just because Schoology is really, really strange to correct, if you have a complex problem to correct, it's kind of difficult for me to grade it that way. So to kind of streamline things, I'm going to put up the questions as separate, like assignments. And then each one of those, you'll just upload the picture of that one question. And then that way you'll be able to tell how many points you got on each question, because otherwise it's kind of just like a sum total of points. And so it should go much quicker for me that way. Now the big thing that we did kind of decide on, because this was kind of the hard part, was the setup of the test. So I knew you guys would want class time for us to answer questions and review. So we kind of set it up where we'll still do that during class time. And not to mention that, but 1 hour is difficult to fit an entire test in. If there's any kind of glitches, problems, you guys still have other classes before and after, So we're going to give the test basically during the normal open help sessions. So you guys will just come on Google Meet, and you can take the test anytime after 1:15, and the last you can submit things is at 3:30. So I guess what I would prefer is you guys just take the test on Google Meet. So, what we've been kind of running into is a majority of the calc students are super honest and, in the class because they're trying to learn it and they enjoy it. But there's definitely a portion of the class that, would basically lie and cheat their way to get through the entire thing if they had the choice. And so part of the reason we wanted to do the test on Google Meet was basically to keep the integrity of everybody. And so the students who are taking the test honestly aren't going to be punished because they're trying it on their own. So if you have some sort of a conflict with this, then that's something, you can work out with me and we'll figure it out. But otherwise, basically you guys should be open during every single day during the normal school day, because that's kind of what you normally had anyway. So I'll be on Google Meet the entire time. You guys can just come on, turn your camera on, take the test. You don't have to say anything to me. You just come on and take the test. Any kind of questions on that? You guys are awfully silent today. I should ask, can you guys hear me okay too? Okay, no, that's good. I've got 17 blank screens right now, so. Okay, well, so that's the details of the test. Like I said, I have the outline up for you guys to look at. Oh, yes, the policy for retakes is just the normal school policy. So if you get less than 70% on a test, you can retake a test up to 70%. So we kind of did that because, well, it was a school policy. AP doesn't really want people doing retests at all, but since that's the school policy, we go by that one. Normally the outline I give you guys, like question number 1 on the outline is going to be question number 1 on your test, but Schoology shuffles the multiple choice questions, so excuse me, the first 10 you take aren't going to be that order. They could be any random order, but the 4 free response questions will just be what they are. Okay. Yeah, I mean, you guys are welcome to put up the questions on Padlet and stuff too if you have them. Otherwise, we have 2 topics that we're supposed to cover yet today. And so this was kind of like the extra day we had because we were going to be going. Oh, I'll go over the outline on Monday, mainly because there's not really time for it today. But that's why I wanted it put up so you guys could at least look at it and try to check things out. So the 2 topics we have left today are actually, you're going to find them very easy compared to what we've been doing. These absolutely have nothing to do with related rates. So these 2 topics are, well, they don't really fit in anywhere great. So they're basically put in this unit just to kind of fill space. So the first one is called local linear approximation. Most people just refer to it as a linear approximation, but you know, yeah, whatever. So if you see either version of those wording, approximation. And the idea behind this is, let me use this quick. Sure. No. Whoop. Get off. There we go. Let's say we have some sort of a parabola. And I'm asking you to estimate the answer at that point. If it's some sort of a... Here, I'll just tell you, I think the idea for this is actually stupid. But the reasoning behind this idea is that if you don't have a calculator with you, that you can use the tangent line and approximate it at a close value. So let's say this white point is some ridiculous number. So like, let's say you're asked to evaluate e to the second minus 1, right? So that's generally something somebody's going to need a calculator for, whatever it is. And, oh, that was a terrible example because I have no idea what e squared minus 1 is equal to. Let me write a decimal so that I can do that. Let's say you're asked to evaluate 1.97 in some sort of a quadratic function that you would never be able to answer without a calculator. The local linear approximation basically is saying you can evaluate a nicer number at a close location on the tangent line because the tangent line is linear, so it's usually easy to calculate. And so then that's kind of the general idea behind local linear approximation, is you use a tangent line to estimate a close location. Now, to me, the idea is just flat out doesn't make sense because a majority of the time you very well need a calculator to do the linear approximation too. So if that's the case, then it's kind of a pointless issue. But, you know, AP tests you on this. And so it's, number one, it's basically super easy points for you on the AP test because it's just like using a straight line to answer a question. So the local linear approximation has a formula to use. If you are trying to evaluate the local linear approximation at any value, so that's x, you are going to take f of c plus f prime of c times x minus c. So this is using point slope form. So this is m x minus x1, and this is y1. Because the normal point slope form is y minus y1, so if you add y1 to both sides of the equation, you would get what's written in pink. So what's written in blue is function notation rather than algebra 2 notation, but it's the exact same information. So it's basically an equation written to give you the y value if you have all of that other information. So there's one question on, maybe two. At least one question on the test on local linear approximation. From your perspective, it should basically be a free point. So what I'll do is I'll write out a sample question. I just went and took a random one from Khan Academy that's you know, similar to what you're going to see on the AP test. So, I mean, honestly, the question writing it out is going to be longer than doing it. So approximate g of 5.1. Oh, I didn't mention it, but you probably understood it. A local linear approximation sometimes can be an underestimate or an overestimate, basically depending on what the tangent line does, and or if you're evaluating before or after it. So for now, you don't have to understand if it's an over or underestimate, but do know that it could be either way. So approximate g of 5.1 using, you know what, I'm just going to say local linear approximation. Oops, sorry. Test multiple choice. Yes, so the first 10 questions are, I think it says after each question on the outline. So after the question, if it says MC, that's multiple choice. And then there are some that are short answer, like a number answer. So I'm going to roughly say there's 5-ish multiple choice questions. So approximate g of 5.1 using local linear approximation at x equals 5, given that g is a differentiable function with g of 5 equal to 8 and g prime of 5 equal to 0. Okay, so on this one that I wrote down, clearly we don't know we don't know the equation because it just tells us g of 5 equals 8, g prime of 5 equals 0. So we don't know the equation. We don't know what it looks like. And it technically doesn't matter. So as long as we have the correct information to use, that's all you need. Now the part that I didn't mention up on my picture up there is this whole local linear approximation depends on the fact that it's differentiable, as in you can find slope, right? So if you can't find slope, like on absolute value, on the sharp point in absolute value, well, there's no slope there, so trying to find a tangent line is worthless. So this local linear approximation only works if it's differentiable, so that's why that's included in the given portion. Okay, so L of x. Well, we are trying to approximate 5.1. And we're trying to approximate 5.1. I don't know if you want me to put a note there. Ugh, so hard to read. What you're approximating. So x is the one that you're focused on. C is the easy value given. And I say given or you choose. So C is the nice number. X is the approximation that you're trying to find. So L of 5.1 is f of C. Well, f of C is 8. F prime of C is the slope, so 0, times x. X is 5.1 minus 5. Now this one's going to work out really easy because the slope is 0. But normally this would be like a 1 or a 2, something like that. So our approximation for L of 5.1 is about 8. So the actual work that goes with this is very easy. Honestly, the hardest part for most people is figuring out what's x and what's c. So that's why I kind of put that little note up there for you guys. Don't forget you can use your notes during the test. I mean, that's the advantage for you guys in this setup. So if you guys take little notes to yourself on where you could get confused, that usually helps you out a lot. How's it going on this? Any kind of questions about it so far? Okay. Is everybody very tired today? I'm getting that sense. So the next one is called L'Hopital's rule. And I've seen it written both ways. And I don't even know if I'm pronouncing it right, but that's how I've always heard. Ooh, wait. Alexandre, you're from you're from France, aren't you? Or live there or something like that? Yeah, that's right. That's I remember. Is that how you pronounce it? What's the O with the little? Okay. Yeah, I mean that's usually how I've heard it. Obviously, a lot of people will call it La Hospitals, but yeah, you kind of pronounce it L'Hopitals. So the reason we never did this before is because this is on finding limit answers. And yes, I know we thought we were done with limits a long time ago. But there were definitely a lot of limits that we wouldn't be able to do in the past. You know what? I'll start with one. I'll start with one that is like you guys already know this answer, and that's fine. Anthony, do you think you could help me out with this one? That's okay. I wasn't looking for, like, I'm sure some people in here remember the answer's 1, but we're not doing that. Why is this one that we can't just evaluate? Like, why can't we just plug 0 in? Perfect. Okay. So if we would plug 0 in, you get 0 over 0. And so that's called an indeterminate form. So L'Hopital's rule is how to evaluate limits with indeterminate form. So 0 over 0, infinity over infinity. And there's actually a lot of other ways that an indeterminate can be written, but that's the two that we focus on because those are the two that happen the most. So it's an indeterminate form, like something you can't figure out. Okay? This is actually a newer topic on the AP test. This used to be on the Calc BC test for whatever reason, and it's actually really easy, but I don't know why it was ever on BC. But they purposely made all the AP teachers go to a workshop last year. Because for some reason the AP is going to be really particular on how you write the work for this problem. And I don't know why, and it doesn't matter that I don't know why. They're just picky about it. So they're picky about some things. And this is on free response the last 2 years, and I'm kind of expecting it to be a free response question this year. And since there's only 6 free response questions, this is big points for you. So here's what you cannot write. And this is where I say I don't know why. You can't write that. They specifically told us that you can't write this because it can't be equal to an indeterminate. And so if you write equals 0 over 0, they automatically mark it wrong. So what you have to write is that you have to say the limit of the numerator is 0. The limit of the denominator is 0. And that creates an indeterminate form. And you guys, you're going to have one of these on the test. So that's why I'm taking the time to describe this to you. Ooh, I saw somebody just type something. How are we going to send in each picture with our phones? Yes. So there's lots of ways you can send in the pictures. The phone's probably the easiest. But I'm going to be setting them up as an assignment rather than an assessment, so that uploading the pictures won't be a pain in the butt. Because if it's an assessment, uploading the pictures is actually really annoying for you guys. If I set it up as an assignment, uploading pictures is much easier, because then you can access it from multiple devices. That's part of the reason why we need to give the test during a set time. I'm going to have to pause. I'm being blinded. How many points is the test? 30. So I did try to put all of that information on the outline. Like I tried to write some description on there for you guys. I know you guys get really nervous about tests, so I'm trying to tell you guys, the test is going to be set up a lot like the homework. So if you're doing well on the homework, you should do well on the test. I'm writing the questions with the same wording and same everything. So it should go okay. So once you find that a limit is indeterminate, what you can do is you can take the derivative of the top and the derivative of the bottom. So the derivative of sine of x is cosine of x, and the derivative of x is 1. So the limit of sine of x over x equals the limit of cosine of x over 1. So L'Hopital's rule is the fact that you can, if you get an indeterminate form as your answer, you are allowed to take the derivative as many times as needed until you get a normal answer. So in this case, now that I have the limit as x approaches 0 of cosine over 1, I can plug in 0 now. Cosine of 0 is 1 over 1. And so this is how you actually find the answer to sine of x over x. Now, I know I showed you guys the squeeze theorem and all that. That's basically how they figured it out the first time. L'Hopital's rule is what makes it a lot easier. Okay, questions on how I have this set up. Now, the types of limits we're going to do this on are traditionally like weird limits that you would never have a chance of doing otherwise. But the problems aren't difficult as long as you remember derivatives. And that was the entire reason we couldn't teach this during the limit unit, because you didn't even know about derivatives. So this doesn't have a great spot to go in. Okay, I'll put up another example. We'll progressively get more difficult. See if you guys can do this one. The limit as x approaches infinity of 3x over 8x plus 2. See if you guys can kind of mimic the way that I wrote the first one on how to figure this one out. And maybe, I don't know, we can do this together if you want. I don't know if you're awake yet. I'm sure you guys had a great time going into advisory at 8:30 to listen to basically nothing. If it makes you feel any better, my 10th grade advisory literally had nothing. I just had to take attendance. At least 11th and 12th grade had something. Eric, how about you? Can you help me out? Why can't I just plug in infinity? Oh, so the method, okay, yes, the method that I taught you guys, yeah, you kind of already know the answer is 3 out of 8 to start with. So the method that I taught you guys was that this 2 is unimportant, so you just cross it off. Is that kind of what you're referring to? Okay, the reason we can do that is because of L'Hopital's rule. So what I taught you guys was the dumbed down version of L'Hopital's rule that works. So, yeah, you're correct. If I just plug in infinity, I would get infinity on the top. This is so annoying to write, and I can't tell you how much I hate it. If I were you as a student, I would hate this as well. This is how you have to correctly write it. So you get an indeterminate because you get infinity over infinity. But we are allowed to take the derivative of top and bottom. So Eric, maybe you can help me with that part. What do you get for the derivative of the top? Perfect. What do you get for the derivative of the bottom? Nice. See, this is a good card. This is a great way to start the day. Okay, and so the original problem says the limit as x approaches infinity of 3x over 8x plus 2 is equivalent to the limit of 3 over 8. And if I plug in infinity in, Eric, what do I get if I plug infinity in place of x? Nice. Okay. This is the mathematical proof of why my method of plugging in infinity works, basically. Okay, but I did try to tell you guys this was the we're starting easy. Maybe I'll leave this one up here and I'll do a problem right next to it, so you guys can have to look at. Gotta go a different color here. Let's do the limit as x approaches infinity of 7x squared over x minus x cubed. And again, some of you guys already might know the answer to this, and that's okay. If you have to show the work, we have to be able to prove it. Let's scroll way down. Uh, Sam. Sam, how is your internet working today? I know sometimes it's going off and on. I saw you were cutting in and out of the meeting, so I don't know how well it's going. Oh, sorry. So I see a question. Is the AP test particular about all? No, Aiden, they aren't. Which is why it was weird to me. I think so. What the AP test saw the first year they gave the test with L'Hopital's rule was that they considered everybody to write the work incorrect. So that's why they made a special point of making sure everybody writes it correct. And that's why they gave a workshop to teachers on how to show work correct. Yeah, I don't know. They're not that particular with a lot of other stuff. So I'm not sure what the deal is with the. I don't know why they are. They're their own company, so you know they don't have to have their reasoning. Sydney, are you there? Maybe. Maybe I already put everybody to sleep. Oscar, are you asleep? Oh, anything. Can you tell me how to go from here? Okay, very good. But why are you taking the derivative? Perfect. Okay. Thank you. So the reason I'm making sure to show you guys the correct notation is so that you do it on the test. So the limit of the top is infinity. Yeah, again, I know this blows my mind. Doesn't matter. So infinity over negative infinity is still an indeterminate. So we can take the derivatives of top and bottom. Go ahead. Sounds like somebody's asking a question. Or not. Maybe somebody hit their talk button on accident. Jacob, can you help me out from here? What happens? So what happens? What's the answer? Yeah. Yes. So these problems are very easy to do. And that's why I don't like that you're forced to show a lot of work. Because a lot of you could just flat out do these in your head and get an answer. I mean, keep in mind, if this question is multiple choice on the AP test, you don't have to show any work. But if it's free response, this is how you have to show it. And it's super annoying. So like, look at how much work I'm doing, and we could have done the original problem in our head. So if you take the derivative once and it's still an indeterminate, you can keep taking the derivative of top and bottom at the same time until you get an answer that is not an indeterminate. Oops. And this was especially why I agreed with you guys that if you had to type this in Schoology, it would take a really long time. Google, I don't like Google's not notifying me. I really should have started on those points. Well, Aiden, I don't have an answer for that. If you write really badly, then you might want to write better. Oh, no problem, Cindy. You guys have tech issues all the time. I totally get it. I was joking around about putting people to sleep. I mean, I'm joking around about that, but I wouldn't be shocked if some of you are sitting in bed in your pajamas watching Kelk. I mean, like, I'm not going to be lying if I'd say my kids have worn pajamas for 24/7 for the last 3 months. And I wouldn't be lying. I've worn sweatpants for the last 3 months too. I like that I only have to dress up on top somewhat. Okay, so now that we did the derivative twice, now when we finally plug in infinity, we'll get an answer. 14 over negative infinity. If you have a normal number over a very large number, the answer is 0. Theoretically, they might consider this an indeterminate, so you could do the derivative again, and the derivative again would be 0 over negative 6, which is 0. So you could do that if you weren't if you weren't positive, like if you're not sure if that's considered an indeterminate. Okay. Do you want me guys to give you a couple more difficult ones to just flat out try on your own? How about a hands, put a little hands up if you want me just to put some difficult up. Like little raise hand button. Okay. That at least gives me notice that you guys are there and listening and not brain dead right now. Go ahead. I'm trying to think of the easiest way to answer that because my answer is going to sound stupid. It's because not every infinity is the same. So 5 infinity technically is still infinity. But even though we know the bottom one is 5 times bigger, because infinity is not an actual number, and it's more of an idea, you don't know if they're actually equal. That's probably the most straightforward answer I can give. So whenever you're dealing with multiple infinities at the same time, you don't technically know the answer until you have it down to like 1 infinity. That's probably the most straightforward way I can answer that. Let's do more 0 ones. Well, let's do limit x approaches 1, x ln of x over x squared minus 1. And I am purposely picking ones that you only have to do the derivative once. So like these are great examples of ones that I would never even have remotely given you at the beginning of the year because you wouldn't have had a clue on how to try to solve these. Like factoring, like whatever doesn't work, just. So see if you guys can do these 2 problems. I'll give you like 5 minutes. And if you want, I can quickly put up the test outline, up towards the end to see if anybody has any questions on it. Let's see, Alexandre. If I'm remembering correctly, I feel like I said your name wrong all the time before. Is it Alexandre? Is it? I remember I always screwed up something with your name and I can't remember what it was. Okay, I will do my best to just. let's see, Bella. I don't know if that's enough time or not. It's hard for me to judge how fast you guys are going. Bella, do you think you got the first one? Okay. Can you just tell me what to do? You know, whatever. Okay. How come it's indeterminate? Perfect. So, yeah. Okay. Okay. What do you do from there then? Okay. Did you get that one? So first times derivative of the second plus second times derivative of first. So you are correct. These you can leave it as x times 1 over x, or you can cancel them like you did. So no, either way is good. So if you want to simplify it, you certainly are always allowed to. You don't necessarily even need to, but yes. Either way, it was product rule, so I guess I should have emphasized that. So good job on recognizing product rule. Okay, so it's equivalent to 1 plus ln of x over 2x. And does that get us an answer? Oh, okay. I didn't even notice if you were still on or if I should call on somebody else. Yep, so 1 plus 0 over 2 times 1, 1/2. Good, very good. So, I mean, it looks like a horribly scary problem to start with, but using the derivatives, it kind of works out nice. AJ? Were you able to get the second one done? Oh. Yeah, that would definitely change it. Actually, you would have ended up with the same answer on accident. That's kind of weird. Oh, okay. Yeah, got it. Yeah, if you would have plugged in infinity, this one would have been infinity over infinity. Derivative again, you get it 1/2. I'm actually kind of curious what this thing looks like then. So if 1 and infinity both have the same answer, it must look like a straight line. Okay, no problem. Lauren, I'm not even looking for you to tell me the whole problem. Can you just guide me on what I should do? Is that okay to help me with that? Yeah, that's why I'm going to guess a lot of people didn't. I'm thinking I cut you guys off early. What should I try to do? I'll do the work. You tell me what to do. Okay? Yeah, yeah. So it ends up being an indeterminate just because plugging it in. Okay, perfect. Perfect. So I'll help you guys out with these. Derivative of 1 minus e to the x. Derivative of 1 is nothing. And derivative of e to the x is e to the x. So the answer is going to be negative e to the x. Because it'd be like 0 minus e to the x. And then derivative of ln, 2 minus e to the x. Derivative of ln of anything is 1 over anything times the derivative of the anything. Okay, so these both look kind of rough. But, I mean, like, let's just see if we can get an answer by plugging in 0. The nice thing about a lot of these is you're going to be given numbers that aren't terrible to use. Wait. Oh. Somebody should have yelled at me. I think I said it correctly to you guys. The derivative of ln of anything is 1 over anything. I don't remember if I said ln or not. There's not supposed to be an ln there. And you can see why it's super easy to make mistakes. Okay, so at the top, if I plug 0 in, would be negative e to the 0, which would be negative 1. The bottom, 2 minus e to the 0 is going to be 2 minus 1. So the bottom is 1 over 1 times negative e to the 0, which would be negative 1. So I get negative 1 over negative 1, which is 1. And those, I guess I'd like to say these are about as hard as you'll run into. And that's why I wanted to put some more difficult ones up there. Obviously, the thing that can make them more difficult is you could have a lot of steps. Like here, I'll give you one example I found, and I'm absolutely not going to write out the correct way. Or does somebody have questions on one of these before I scroll down? Okay. So here's an example I found that I would consider to be the worst one possible. And you'll see why in a second. It looks somewhat harmless to start with. And this is, do not copy this notation, obviously. You'd get e to the infinity, which is infinity. Infinity to the fourth, which is infinity, indeterminate. So then I do derivatives. This is how they used to let you write L'Hopital's rule. E to the x squared is e to the x squared times 2x. 4x cubed. Well, infinity times infinity, infinity. And then all of a sudden you can realize why this is going to start getting horrible, because now I have to do the derivative of this as a product rule. Well, the top is always going to be infinity, because it's just going to be like infinity plus infinity or infinity plus 2, whatever it is. And once you do the product rule, you're going to have to do the derivative of 2 product rules. It's garbage, because the bottom is going to take quite a few steps to get down to a normal answer. You're going to have infinity over infinity for quite a few steps. And you're basically going to be able to see the pattern to get down to here. But I would never want to take the derivative of the top that many times, because it would just be horrible. And you finally get to the end, you get infinity over 24, the final answer is infinity. If I had to write this problem with correct notation, it would take me like 3 pages. So this was one of the examples I saw in Khan Academy homework. Now, the good thing about homework is you don't have to use correct notation. I'm only showing you specific correct notation for if you have a free response question. If you are doing scratch work, I don't care how you show it. So like on the test, I want to say there's 2 or 3 L'Hopital's questions on the multiple choice part. You can write it as little or as efficient as you want. You don't have to write correct notation on multiple choice. This one would have been atrocious on free response. Okay, I know we only have 8 minutes left. Do you guys want me to put up the outline just to answer any questions from it, or if you guys already looked at it and basically asked what you wanted? Does anybody have a preference? Yeah, go ahead. Or did you hit unmute on accident? Yeah, okay. Yes, I've done that by unplugging my mic a bunch of times too. Yeah. So the free are you talking about like on multiple choice? So on the multiple choice part, I don't care anything about the work. They're just going to be 1-point questions each. So there's not going to be partial credit or anything. So you don't have to show any work for those at all. No. On the free response question, like that is the whole thing is what you write down. So the free response question is I'm just going to, write the question out for you, and you write the entire thing on paper and submit that. Is that kind of what you're asking? Okay. Yes, Cheddar, I can put it up. Oh, yeah, you're right. Thanks. I forgot about. So he didn't even use Khan Academy. He was using these other kind of packets that he has. So we don't even have to agree. We did different things for homework on this unit apparently. So what I thought was kind of fair is I'll add 10%, because especially since I added a day, I think it'd be really easy for everybody to do the unit test, on time. And so I think 10% should be pretty fair, because honestly, I was really happy to see how many people were already at 90%. So I thought 10% seemed like a fair amount to add. Some of you aren't even going to need it, I don't think. So is that what you're kind of asking? There we go. So this is basically kind of what I was referring to. 10, let's see, I can count them up. 1, 2, 3. Oh, you know what? I didn't even write multiple choice or short answer after these. So I'm going to blame that on lack of sleep. I wrote up the outline at like 11 o'clock last night. And, there's probably even a lot of spelling errors here. I was tired. But these 10 will be shuffled. So the first 10 questions can be any order, but it's on those 10 topics. So determining a particle is moving left, right, and either from a graph, if a particle is speeding up or slowing down from a graph. Question 1 through 4 are all from the first day's questions out of Khan Academy. So that was the day I was sick, and you guys basically worked straight out of Khan Academy. So you should be familiar with those questions already. And I'll absolutely do some for you on Monday if you want to see them. You will notice, I know most of you were probably way more stressed about related rates than everything. And that's just because those problems are so slow and they're complex. So I only have 2 related rates on the free response. And then I only have 2 on multiple choice. So the 2 on multiple choice, it's going to be a very straightforward problem. You're just going to be giving a number answer. The 2 free response questions on related rates are going to be like multiple parts, like I'm going to want to see all the different work out of it. These are probably the ones in Khan Academy. I think they were labeled multiple related rates. Yeah, go ahead. Mm-hmm. Okay. Oh, you must be one of the 5 people that haven't signed up yet. So on the first day of class, so If you go into the folders and go into the first folder, so like, what was that, November 30th? There's a link in there that you're supposed to click, and that allows you to join my class, and it allows me to see your scores. If we have troubles, then I can just have you, come onto Google Meet and share your screen with me, and I can just write your score from there too. Mastery percentage, yeah. So they basically, for some reason, they talk about all these different points, like it'll say you've earned plus 120 mastery points, but it doesn't really show it anywhere. In the upper left-hand corner of your screen, it should show you like a percentage that you're at. I don't even remember how I put it in there, but yes. So apparently, I'm assuming that's the Americanized version of L'Hôpital's. So if you go look at like Wikipedia, they have multiple spellings of it. Sydney, yes. So the test is sort of timed. The multiple choice part is timed. I put 60-minute time limit on there. Honestly, you're probably going to fly through those questions though. So like, I'm going to assume somebody who's a slow test taker should be done with it in a half hour. The free response questions aren't necessarily timed. They have to be submitted by 3:30. So, I mean, there's kind of a time limit because you're taking the test within a 2-hour window, but I purposely made the test to be able to be finished all under an hour. Like, for your guys' sake and for my sake, there's no reason to give a giant test. And it's 30 points total, but the 30 points total shouldn't matter because it's a test category, so it's its own category. Okay, oh, it's 10 o'clock. We're technically past time here. All right. I'm going to be on, I'll be on the office hours today from 1:10 to 2:30. So if you guys have questions about anything, feel free to stop by and ask them. Like I said, Monday morning, we're going to spend the class hour just going over anything you guys have questions on. This isn't something where you should be like, if you've been doing your homework on time when you're supposed to, this isn't a test that's intended for you to have to like cram for. Like I want to try to plan the tests so that if you're doing the homework, the test isn't something that you have to plan extra hours for, like that. I don't like that setup. I don't want you guys to have to, because like I know I've had students that study for like 10 hours at a time. That's just not good for you. I mean, like that's 100% not good for your brain. Okay. Thank you guys for coming today. Hopefully you wake up a little more for second hour. Maybe you can go make fun of La Hospital some more. That'll help. All right. You guys have a good weekend. I'll see you later. You bet. You're welcome.